So let's look a little more at chapter 23 with the kidneys. And so these are all the functions that are related to our kidneys. So the kidneys are very busy, to say the least. So the goal through all of this is helping to regulate a lot of systems in the body. So we can't look at the kidneys as only excretory. We have got to look at them being associated with all these other systems: bone, vessels, digestive, all these other systems in the body.
What are free radicals?
Free radicals. This is where when there is a chemical reaction or, chemical reaction within the body, and it releases for the most part, oxygen is O2, all right? Anything that can break that oxygen molecule leaves us with only one. And when that one oxygen molecule is free, they say it's a free radical because it is so unstable, it's bumping into anything that it comes into contact with and breaks those apart, which could be healthy molecules. So what it's trying to do is it's trying to find something to bond with. Because if you remember in the structure of oxygen, based on its makeup from electrons, based on the periodic table, it has 6 in the outer shell. The outer shell is happy when there's 8. So it's looking for 2 electrons, and it will bust into other molecules looking for something to connect to.
Was there something to do with, I guess, as we age, then our skin gets thinner, I guess, and then it's kind of breaking down all of the fiber, collagen?
It does, and that's why they try to tout all of these products to us, okay, about being beneficial and stopping free radical damage and all this sort of stuff. But we also have to remember that as we age, we're seeing the breakdown of one of the major fibers of our body, which is collagen. And that is going to happen. I mean, genetics can play a huge role, because you can see people who are like 80 and they look like they're 60, okay? Genetics can play a huge role in that. And then there are things that just, no matter what, you can't stop it. I mean, you might see people who are 50 and look like they're 80, based on wrinkles and all that sort of stuff. And a lot of it is the breakdown of those building materials that are occurring. In the urinary system, all right, so we say that the kidneys are for filtration. Well, you can see that the kidneys are for a whole lot more than just filtration. But yes, getting rid of waste is important. Now, here's the thing. A lot of times when we think about waste in the body, we're thinking about our foodstuffs. Foodstuffs that the body either gets materials from and then keeps sending it on its way, all right? As we break down the foodstuffs, as it continues through the small intestines into the large intestines, it becomes feces. That's food waste, okay? We also have in the body that metabolic waste, which means all of these chemical reactions occurring in the body, and their products that get created. And in some of the products, there's always waste. a lot of the waste that occurs from the metabolism of our body creates nitrogen waste. Nitrogenous waste are the most toxic to our bodies. One of the biggest is urea. Now, we tend to associate urea urine, okay, but this is actually a nitrogenous waste that is created by the majority of the cells of our body. So, it's a byproduct of anything dealing with protein breakdown. So, remember, proteins, these are amino acids. We have to have that available. And one of the ways we have to think of it as, okay, well, I consume my food products. Food products are going to hopefully have proteins that my digestive system can break down so that I can get those amino acids, which are the component parts of it, into the cells that need those amino acids to build a protein. Then once it's used, all that's got to be broken down so that those amino acids can go back to the bloodstream and be used again. We don't store them. So this constant use of proteins, which is huge because at any point in time, you're 50% proteins, if not more. Okay? So anything that deals with their breakdown produces urea, a nitrogenous waste, because the huge molecule on an amino acid is a nitrogen. That's part of their amine group. Okay? So, that will actually get released and create this urea in the blood. It can actually be tested. It shows up as bun on a blood report. It's done all the time. Go to the doctor. They draw the blood. You're going to come back with the results, and one of those results is going to always be bun. Have you ever looked at your blood test results? No? What? Okay, y'all. You'll do that now because y'all taking my class, and it's really cool, okay, because you'll know now. You'll look at them and you'll be like, that's what Dr. Burnett was talking about. Okay? There's a norm that should exist, about 10 to 20 milligrams per deciliter. You know, not a whole, well, actually, that's kind of a pretty good amount. And it's cool. If it falls within those levels, this means your kidneys are pretty good. You're getting rid of the wastes. Okay? But if you begin to see that number go up, now look, if you have a blood, because I'll never forget the first time I saw an elevated bun on my blood work, okay? I freaked out, all right? I was like, whoa, whoa, whoa. What's up with my kidneys? And my doctor was like, bless her heart. Y'all know she has a hard time putting up with me, right? Bless her heart. She's like, Nat, were you very well hydrated that day that the blood was drawn? And I'm sitting there. I'm never well hydrated. And she goes, chances are you just were not well hydrated. So let's do this. I want you to stay hydrated for about 3 days and come back and have your blood drawn again. And it was fine. All right? So dehydration can be a major factor. Now, if the bun gets elevated, stays that way, well, then we might be running into some trouble because it can represent renal insufficiency. Kidneys not working properly. If it gets too high, stays that way for an extended amount of time, we call it azotemia. If it continues and if the issue is not addressed, i.e. dialysis or other treatments, you can usually die within a few days because the nitrogen wastes are toxic. And if the body's not clearing those wastes out, then yes, the kidneys are not functioning, and it is a major, death is a major side effect of the kidneys not functioning correctly. That's just point blank. And all of it builds up in the tissues and causes death to the tissues, i.e. causing death to the organism. And I see that I forgot the W. Okay, typo. Some of the other wastes that are included: uric acid. Ever heard of that one? Okay. People who have gout have uric acid crystals. This is actually crystallized. They usually end up in a joint of the body, causing that severe pain. You have to kind of wait for the crystals to decrystallize, blah, blah, blah. Okay? We get that from the breakdown of nucleic acids. DNA, RNA, tRNA, mRNA, okay, nucleic acids. And then another waste, creatinine, from the breakdown of creatine phosphate, which is another form of energy for cells of the body. It's very short term though, nothing like being compared to glucose. So the functions, keep saying this, excretion. The goal, kidneys filter what gets sent to them by way of the blood. Take what is in the blood, separate those materials, return to the body the materials that are needed. The rest of them, urinate them out. That's the goal. But now, look at the organ systems that are involved. My respiratory system, my integumentary system, my digestive system, urinary system. When we talk about excretion, these help excrete waste, but are nothing in comparison to what my urinary system can do. Yes, it's excellent. For example, that with my integumentary system, I can get rid of some waste. That through my digestive system, I can get rid of some waste. But for my blood to be properly filtered and not have a high waste level that can be damaging to the tissues of my body, my urinary system needs to be functioning correctly. I need for it to take care of a huge amount of metabolic waste. I need it to help with toxins that we're exposed to every day, food, water, air, whatever the case might be. Drugs, a lot of our filtering of medications and other drugs are done with the urinary system. Some go through the integumentary system. Hormones, salts, hydrogen ions, water. But anything that's going to be beneficial, I need to return to the system. For example, glucose. I need for that glucose to not go out through my urine. I need it to go back to the blood for the tissues to use it.